How to find GCF using factor trees. To find the greatest common factor, or GCF, using factor trees, there are 5 steps. 1. Find the prime factorization of all term coefficients, the number part. 2. Expand all variable parts of the term. 3. Circle and cross both coefficients and your variables. Step 4. Multiply all circled numbers. Step 5. Write answer in GCF notation. Let's look at an example. Let's find the prime factorizations of these two terms in order to find the GCF quickly. 350 is even, which means 2 goes into it. I will have to do some division by 2. A quick bit of division shows me that 2 going into 350 has the quotient 175. 2 is prime. 175 is probably not. It's not even, so 2 doesn't go in. So I'm going to add 5 plus 7 plus 1, or 1 plus 7 plus 5. That gives me 13. 3 does not divide 13. It ends in 5, so 5 must be a factor, and 5 is prime. A quick bit of division reveals that 35 is the quotient of 175 divided by 5. 35 is not one of my primes, so I must do this again. It is not even, so 2 won't go in. 3 plus 5 is 8, so 3 won't divide because 3 doesn't divide 38 very nicely, so it won't divide 35. It ends in 5, so 5 must be one of the factors. Well, 35 divided by 5 I know is 7, and 7 is a prime. All of my branches are prime, therefore I'm done. Writing them in order, 2 times 5 times 5 times 7, I have it expanded. I'm going to do the same thing now with my variables. The variable piece I have to expand. Times x times x times y times y times y times z. I have my entire problem expanded out. Let's do the next one. 125 is not even. 2 and 1 make 3, plus 5 more is 8. 3 won't go in, so my next prime is going to be 5. 5 goes in, so I need to divide out to figure out what it is. Quick division shows me it's 25. 25 is not prime, so I need to keep going. 5 goes in, 5 and 5, so now I can write out my factors from least to greatest, and then add in my variable piece expanded. And 5 z's. All right. Now we have done part 2. Expand all variable parts and terms. Step 3, circle cross. We're going to do this even with our numbers, our coefficient factors. I don't see 2 in both of them, but I do see a 5 in both of them. So I'm going to circle and cross out his partner. I'm going to circle and cross out his partner. I'm going to circle an X and cross out his partner. I'm going to circle a Y and cross out his partner. Circle a Y and cross out. Circle a Y and cross out. Circle a Z and cross out. The last step is multiply all of your circled numbers and write the answer in GCF notation. We also need to multiply our variables. In other words, we need to put them in simplified form. So we can write our answer finally in GCF notation. Pause your video and see if you can get the answer. The GCF of 125x y cubed z and 350x squared y cubed z, least to greatest, is 25x y cubed z. That 25 came from 5 times 5 is 25. We multiplied all our circles. I'll give you one more to see if you can do it. This time we have 3 terms. We need to pay attention to the fact that there seems to be no number here and no number here. That means we have a ninja. We're multiplying, so our ninja is 1. This is going to be important. Pause your video and look at your factor trees. Your factor trees look funny with the 1. The reason for that is that they're the identity. The only thing in common really is the fact that it's a 1. He doesn't have any other factors. If we look here, it looks like nothing's in common across all 3 of them. It actually is, because 1 is always a factor of every number. So our GCF for numbers is 1. Then we get to do our variable. Remember, we're not multiplying all 3 terms. We have commas in between. The only thing I see in all of them is a y. So our answer is 1y, or just y. One last thing. If you have a prime number, like 13, he already is prime. He is already the end branch. Done. He could have 1 as a branch.